This video is designed to allow you to distinguish between different types of matter, specifically substances: molecular, ionic, network, and metallic. Within those categories, we will further break them down in terms of their properties. But if you can first say, oh, that's a network or that's an ionic substance, then you know something about it right off the bat. And you should be able to look at a formula and know that. So let's start with that. Let's start with molecular substances. Now, what is a molecular substance? Well, what's a molecule? A molecule is basically a single piece of matter that can move independently of a second piece of matter. Some molecules are monoatomic. Now, there's really only four of these guys out there. And the four that are out there are basically these four right here. These four noble gases always occur as single atom molecules. So you can have a single molecule of neon and another molecule of neon, and they're able to go bing, bing, bing and move around independent of each other. At some point, as you get the temperature low enough, they'll stick and you can have liquid neon or liquid argon or krypton. But those are single atom molecules, and that's what a monatomic molecule is. The reason why I'm distinguishing this is I want you to say when I talk about a molecular substance, it doesn't always have a covalent bond. Okay? For noble gases, they're considered molecular because a single atom of neon can move separately from another atom of neon. They're not stuck to each other, at least in the gas phase, right? Okay, all the other molecules are diatomic or more. So you have, and they always consist of the following elements. This is the nice thing about it. If it's not a monatomic molecule, then it does contain a covalent bond. This is always kind of a point of confusion. Well, what is a molecule? It's an individual piece of matter. Okay, but most of them contain more than one non-metal atom connected by covalent bonds. So O2 is a molecular substance, right? It's got two bonds here, right? And you are drawing Lewis structures of molecules and polyatomic ions, right? That's a molecule. C6H12O6 is another molecule. All right, it's got 24 atoms in it total, but all those atoms are connected by dashes, right? Now, how are you going to recognize a molecular substance that contains covalent bonds? Well, the good thing is there's a limited number of elements that actually make these things, okay? And I'm going to mark them off on the table right now. There's hydrogen. And then look how I'm bracketing this up. Now, there are some things like boron, we'll see, can be in there too, and so can beryllium, right? So because we saw those like BF2 and BCl3. But generally, we're talking about this area right here. These guys right in here, okay? Hydrogen, okay? And all these guys in here. A literal total of maybe like 11 or 12 atoms are the ones that are in molecular substance. So you see a NO2, and it's not that's a molecular substance, right? CO2, it's a molecular substance. XCF4, molecular substance, containing covalent bonds. Some of them are polar, some of them are nonpolar. Some are symmetric, some are asymmetric. But those are molecular substances. Just nonmetals. With some small exceptions like BEF2. Moving on. Ionic substances are usually going to come in two different categories. They are either binary. So a binary ionic substance will have a metal with a non-metal. So you see like Na with Cl, right? So a metal, right, with a non-metal. That's binary ion. Ki, potassium iodide. A metal with a non-metal. A thing that lost electrons, the metal, forming a cation sticking to an anion, right? Forming a crystal lattice with a certain amount of lattice energy, which we learned about before in the earlier unit, right? Now, other ionic substances are ternary or quaternary, and these are the guys that contain polyatomic ions, right? So if you see like KNO3, that's ionic. Now, in terms of characteristics, it's going to behave just like NaCl. Okay, so when this dissolves, it doesn't break up into K and N and O's. It breaks up into K plus ions and NO3 ions when it dissolves in water, right? Now, make sure we're clear. This substance has both ionic and covalent bonds, and that was on the previous worksheet. A lot of people were getting wrong, okay? And the reason why it has covalent bonds is within the polyatomic ion that you just drew, okay, there's a covalent bond. And if you're paying close attention, I said on the last worksheet of monster bonding, hey, polyatomic ions, okay, we don't talk about whether they're polar or non-polar. They have an overall charge. But they're found in ionic compounds, okay? So if you see any polyatomic ion, and it's not an acid, it's an ionic substance. So if you see ammonium chloride, hey, that's a polyatomic ion and a chloride. That's ionic. If you see CaCl2, if you see vanadium oxide, that's a metal with a nonmetal, right? Right? Those are all ionic compounds. Okay, this is a binary one. This is a binary one. This is a ternary one. Okay, if you have ammonium nitrate, that's made of 2 polyatomic ions. So, okay, now the ones that these ones here, like I'm putting little X's next, they also have covalent bonds in them, and you should know that. But it doesn't really affect their properties. Okay, because most of the time when these guys react, they're involved in double displacement reactions, or they're dissolving, in which case the ions are separating, but the nitrates or the ammoniums or whatever the ions are, the phosphates, they stay intact. So these are considered ionic substances that just happen to have covalent bonds as well. Next grouping. Metals and alloys. Now metals are all the guys in here, as well as obviously the ones down here they didn't bother with in the picture. Okay, we'll talk about their properties, but you should also know part of the unit is going to be involved identifying alloys, so I'm going to mention those now. Now, the key thing about metals is they don't form compounds with each other. So you'll never see a compound with copper and zinc. However, you can mix them together, but they're not a compound because they don't have a definite ratio. Okay, copper zinc is brass, right? In 10th grade, we made brass-covered pennies, okay? And all we did was we mixed some zinc in with the copper on the surface of the penny. But the ratio for this can vary. It's essentially, okay, a solid solution. So metals are just going to be like a symbol for a metal or a symbol for a metal, or it could be like Fe with carbon, that's steel. That's an alloy. So it doesn't even have to always be a metal that alloys with a metal. It could be a non-metal. Carbon is what's in steel. Okay, you could have copper with tin. That's not brass. That's bronze, right? Okay, you have chromoly steel. It's got chromium, molybdenum, and iron, and carbon. So I will get into alloys later, but metals have what's called a metallic bond. They do not form compounds, and they have very different properties from molecular things and from ionic things. And now I'm going to talk about networks. All right, networks are something we haven't talked about at all year, and they are like a huge amount of what we see around us. All right? Networks generally involve certain elements, and I box them off here. And there are more. So when I get into the later, we'll talk about some of the other ones. But for now, what a network is basically this. You have a carbon, and it can connect to 4 of the carbon atoms, which connect to 4 of the carbon atoms, which connect to 4 of the carbon atoms. And they are basically a big network of atoms connected by covalent bonds. The ones in group 14 tend to be involved, but that you can see networks that involve these groups here and these groups here. In fact, one of my students is working in your class is working with a network solid when they did their science project. Okay, gallium arsenide. That's a network solid. Gallium is here, arsenic is here, okay? And it's basically a big network of covalent bonds. All right, and the way you're going to just recognize this, you want to look for certain elements. Now, the thing is, they're never going to ask you about gallium arsenide on the AP exam. They're going to focus on 3 elements: carbon, silicon, okay, and maybe germanium. As elements, these guys form networks, okay? Branching networks. Now, a single diamond is basically a big network solid, where all the carbon atoms are connected to all the others. You can think of it as a really big molecule, but it's very hard, okay? So a single diamond is literally one piece of a substance. It's like a monster-sized molecule in which every atom is connected by covalent bonds to the other atoms. How you recognize networks? Look for carbon, silicon, germanium. I'm just going to give you the examples that you should know. Combination, for example, and just mention some types like quartz. You should just know it's silicon dioxide. It's found in ceramics. It's found in glass. Okay, all ceramics involve some sort of what they call silicates. It might not be SiO2. It might be SiO3, but it's a combination of silicon and oxygen forming a network. Okay, germanium, silicon by themselves form network solids. They're also what they call semiconductors. I'll talk to you about that a little bit later as well. Ones you should know. You should know diamonds. Just know it. You should know graphite is a network. Graphite is also made of carbon. It's an allotrope of carbon. The way the atoms are connected is different. We'll get to that in a later video. You should know silicon carbide, SiC. It's one of the hardest substances known to man. Okay? The other substances are quartz, which is really hard. That's number 9 on Mohs scale. Diamonds are number 10 on Mohs scale. Silicon carbide is probably harder than both of them, I think. I'm not sure, though. But notice, silicon, carbon. Just look for it, okay? If you see something with silicon, carbon, and it's not like an organic molecule, like this doesn't count. This is methane. That's a molecular substance, right? Sugar is obviously not a network solid, okay? So if you're looking for carbon in a network, it's either silicon carbide or straight up carbon. They've got to give you extra information, but it seems like on the AP, looking over the curriculum, they kind of expect you to memorize SiO2, diamonds and graphite and silicon carbide. That's the way I'm looking at it from my perspective as being network solids. All right, let's take a look at the next page. All right, let's take a look at what we have here. We have a huge list. Now, what I'm going to do is I'm going to just put the numbers in, and you should go back through the video if you don't get this right. So, if I put a 1 next to it, it's a network solid. If I put a 2, it's ionic. If I put a 2, that's supposed to be an A. If I put a 2A next to it, it's ionic with covalent bonds, meaning it's ionic, but it's got a polyatomic ion. If it's just a metal, I'm just going to put number 3. But if it's an alloy, like it's a mixture of 2 metals, or it's a mixture of iron and carbon, which is steel, I'm going to call it an alloy, give it a 3A. If it's molecular, I'm going to give it a 4. If it's a monoatomic molecular substance, which means it's a noble gas, I'm going to give it a 4A. Subsequent videos will talk about the distinct properties of all these different groups, okay? But the first thing is to be able to just look at it and say, snap, I got that. I know it's a this, that, or the other thing. So I'm going to pause this, and I'm going to give all the answers, okay? And after you watch this, if you have questions, you're to give me questions. Okay, I hope this helps. The one I left out here was J, and that's because, well, you might think it's, I'm expecting some people are going to say it's 2. If you Google it, it's actually a network solid. And that's sometimes when it gets that middle section there, aluminum's right near the line there, and nitrogen is 2, things can get a little iffy, all right? So they would have to say something. Like they would have to say that aluminum nitride is very, very hard, or something along those lines. That would be a giveaway to tell you what it was. I hope this helps.